Thank you to Factor for sponsoring this video. Head to factor75.com or click the link below and use code 50BizarreBeasts to get 50% off and free shipping on your first Factor box.
Bad news, the ocean is full of spiders. Sea spiders, that is. They're not actually arachnids, although they certainly look the part. They also don't have a ton in common with other chelicerates, which is the group that includes arachnids, horseshoe crabs, and the extinct sea scorpions. And they maybe don't, have a ton in common with other arthropods in general? Point is, they're weird guys, and the specifics of their strangeness may actually help us to better understand how all of these different invertebrate groups evolved. And as we investigate the common traits of a beast this bizarre, we end up finding our way back to an ancient branching point within the most diverse group of living things on the planet. To keep this channel going, the Bizarre Beasts Pin Club is open for subscriptions for the whole month. Sign up by November 20th, and the first pin you will get will be a sea spider. Sea spiders are any of the roughly 1,300 species of marine invertebrates in the class Pycnogonida, a name that aptly means dense knees. And if you look at them, they sure do have a high density of knees. A pycnogonid looks like if you asked somebody to quickly draw a spider from memory and all they could recall was legs. Some walk along the seafloor while others swim. They can be as small as just a few millimeters or as large as 75 centimeters. And they can be found all over the world, from coastal shallows to 7 kilometers deep. And it's the species that live way down deep or in the cold waters of Antarctica that represent the upper end of that size range due to the related phenomena of both polar gigantism and deep sea gigantism. Basically, as you travel to parts of the world with colder and colder temperatures, you will find bigger and bigger animals, whether you're moving farther from the equator or deeper below the waves. The evolutionary explanation for larger bodies being better adapted to colder environments is still debated, but the top contenders are better metabolism, fewer potential predators, and more efficient oxygen use. We're actually going to talk about that last point in a minute. Like true spiders, sea spiders have a cephalothorax and an abdomen and 4 pairs of legs. But unlike true spiders, the pycnogonid's cephalothorax is thin and includes a proboscis for eating with, an abdomen that is downright tiny, and in some species, they may have 1 or 2 additional pairs of legs. And all of those legs have more joints than the legs of any other type of arthropod, with leg segments that are just a bit different from anyone else's. This leggy body layout is multifunctional, and their legs aren't just for getting around. They also have several specialized types, including legs for eating with, pedipalps for sensing and grooming, and some species have especially unique limbs for reproduction and offspring care called ovagers. They reproduce by holding their ovagers against those of the opposite sex, and then the fertilized eggs attach to the male's ovagers, where they stay until they hatch. So yeah, they reproduce with their legs by releasing sperm or laying eggs out of their legs. This is because with such a tiny cephalothorax and abdomen, organs like the reproductive system had to go somewhere. And it really is kind of all legs with these things. For example, they also breathe through their legs and use them for circulation. Pycnogonids do not have gills or any other specialized respiratory structures, so they do all of their gas exchange right through their exoskeleton. And although they do have a heart, for some of the really big Antarctic species, it doesn't create a strong enough flow to get to every body part. Luckily, their gut reaches almost all the way into their walking legs, so as oxygen diffuses into their legs from the surrounding water, they use peristaltic muscle movements to squeeze fluid into those gut extensions, moving oxygen from the legs into the rest of the body. And to be clear, despite all of this complicated fluid exchange happening in their extremities, sea spiders still do all of the actual limb movements via normal muscles. They just also happen to have a big leg stomach that pumps their blood so they can breathe. You know, normal stuff. At the very least, this does answer an important question for pycnogonids: is gut legs? Their wacky appendages did not just earn them the name of their taxonomic class either. Sea spiders also belong to the order Pantopoda, which literally means all legs or all feet. But this order actually is more of a compromise between disagreeing taxonomists than a true classification. It encompasses all all extant sea spiders, and it doesn't exactly help narrow down how these guys came onto the scene in the first place. Part of the problem is that scientists have disagreed for a long time about where sea spiders fit into the tree of life in general. Are they arachnids? They resemble regular spiders, but there's that sticking point of some pycnogonids having more than 8 legs, and their overtures are a unique feature that you will not find on any arachnid. So let's go up one taxonomic rank. Chelicerata is the subphylum that encompasses arachnids plus horseshoe crabs and some extinct species with similar vibes. Sea spiders have the telltale claws on the front of their bodies, on those feeding legs we mentioned, that help identify chelicerates. But then they also have features like the proboscis, which can't be found in any other chelicerate species. This has led some scientists to categorize them as an outgroup to chelicerates, or else as an outgroup to all other arthropods. But then we go up to that next level, to the whole phylum Arthropoda, and we still find ways pycnogonids just refuse to conform to our definitions. Arthropods can be generally described as invertebrates with exoskeletons, segmented bodies, and jointed legs, and at a glance, sea spiders tick all of those boxes. But their unique reproductive structures, atypical joints, and ability to grow between molts, not to mention the substantial leg real estate that their major organs occupy, all make pycnogonids serious outliers. So why don't we just use DNA to solve all of this? Taxonomy is a human construct, but something as fundamental as genetics should give us a more concrete answer, right? Well, sea spiders are actually too weird for this. Thanks to the way their digestive systems extend into their legs, their tissue samples can be very easily contaminated with the genetic material of whatever the sea spider ate, especially for the smallest species. Luckily, we do have some other tools available to us, like embryology. Comparing the developmental stages of different taxa can offer us clues about how they are all related. In the case of sea spiders, they start off life as basically just a head with a few small extremities, gradually growing more segments and more legs as they develop from larva to adult. This same developmental pattern is common in other arthropods, especially in crustaceans. Researchers initially suggested that the rough similarities here could mean that pycnogonids represent a more ancestral developmental strategy among arthropods. But that has since been dismissed in favor of the possibility that the whole head larva way of doing things evolved multiple times convergently across arthropods. And sure enough, a comparison to similar-looking fossil pycnogonid nymphs supports this hypothesis. So what exactly do we get from all of this? In short, sea spiders have enough in common with enough different arthropods for us to include them in that phylum, and enough in common with chelicerates for us to at least group them in that general vicinity. But with all the truly wild traits that these odd little dudes display, scientists have concluded, at least for now, that Pycnogonida most likely split off in the early Cambrian, around 530 million years ago, to become a sister group to all modern chelicerates. Sometimes what makes an animal bizarre is just how different their shapes, behaviors, and lives are from what we are used to. And sometimes it's how hard we have to work to fit them into a nice human-defined box. For sea spiders, it's both. And that double whammy of weirdness is actually helping scientists better understand the evolution of arthropods as a whole, and given that they are the most diverse taxon on the planet, that's a pretty big deal. So maybe an ocean full of spiders that are made entirely out of legs is good news after all. Joining the Pin Club at BizarreBeastsShow.com helps us keep making these videos. If you want the Sea Spider pin to be your first pin, subscribe by November 20th. You can't do it after that. You will never get that pin. Now, for some bonus facts. If there is one thing that Bizarre Beasts shares with its sister shows at Complexly, it's that we love a good fact about butts. In a study published in January of 2023, researchers discovered that juveniles of one species of sea spider were able to regrow their back ends after they were experimentally amputated. The sea spiders regenerated at least 2 of their back legs, their reproductive systems, portions of their digestive system, and their anuses. They regrew their butts. The adult sea spiders that took part in the study study were not so lucky. They did not regrow any body parts, and half didn't survive. And that might be why scientists hadn't realized sea spiders could regenerate lost body parts. They'd been looking at the adults, not the juveniles. The second bonus fact is, remember those giant Antarctic sea spiders we mentioned earlier? Well, in most species of sea spiders, the males carry the eggs around on their legs until they hatch, and sometimes even after that. It's exclusively the males who do the parental care. But in one species of giant Antarctic sea spider, one of the parents, probably still the father, attaches the eggs to the seafloor instead. Their microalgae grows over them so they blend in with the rocky bottom of the ocean, which camouflages the eggs and provides them with protection.
Sea spiders eat soft invertebrates they find on the seafloor, but thankfully, you have more options, like the ready-to-eat meals from Factor. Eat stress-free with Factor's delicious ready-to-eat meals. Every fresh, never-frozen meal is chef-crafted, dietitian-approved, and ready to eat in just 2 minutes. Choose from a weekly menu of 35 options, including popular options like Calorie Smart, Keto, Protein Plus, or Vegan and Veggie. Also, discover more than 60 add-ons every week, like breakfast, on-the-go lunch, snacks, and beverages to help you stay fueled and feel good all day long. Factor meals eliminate the hassle of prepping, cooking, or cleaning up. Simply heat and savor the good stuff. Today, I had the roasted tomato and feta cavatappi with broccoli and red peppers. The tomatoes really make this for me, but the broccoli balances the whole meal out very nicely. Head to factor75.com or click the link below and use code 50BizarreBeasts to get 50% off and free shipping on your first Factor box. That's code 50BizarreBeasts at factor75.com to get 50% off and free shipping on your first box.